places on Earth where logic should have drawn the line, where gravity, terrain, and risk said stop, and yet humans built there anyway. We're talking about structures hanging over abyss-deep valleys, carved into mountains that constantly move, or holding back forces powerful enough to reshape continents. Projects so extreme that a few centimeters of error could mean catastrophe. And sometimes nearly did it. These aren't just impressive buildings. They are calculated gambles with physics, tests of ambition, proof that engineering often walks a razor's edge between brilliance and disaster. In the next few minutes, you'll see constructions pushed into location most people wouldn't even dare to stand, let alone build on. Some solved impossible problems. Others rewrote what we thought was achievable. So stay with me, because by the end of this journey, you may look at the modern world very differently. Let's begin. Stretching nearly 8 kilometers across open water, the Mackinac Bridge doesn't just connect two land masses. It connects two worlds. Here, in the rugged straits between Lake Michigan and Lake Huron, engineers had to tame nature's raw forces to bind America's upper and lower peninsulas together with steel, cable, and rock. Known locally as the Mighty Mac, this suspension bridge was completed in 1957 after years of planning and construction under conditions that would unsettle even seasoned builders. Designed by David B. Steinman, it became a testbed for aerodynamic stability, incorporating an open-load grid deck and deep stiffening trusses specifically to withstand the punishing winds that roar through the straits. At mid-low span, the roadway hangs roughly 200 feet above the water, supported by massive towers that rise over 550 feet high. Steel giants anchored deep into the cold lake bed. Yet the drama isn't just vertical. In severe wind conditions, the center of the suspended deck can shift as much as 35 feet sideways, a controlled dance between structure and storm. When it opened, the Mackinac Bridge became the longest suspension bridge between anchorages in the Western Hemisphere, a title it still holds decades later. For decades before, ferries were the only way to cross. Now, whether it's freight trucks rumbling across or families driving into vacation country, this singular span has redefined connectivity in a place that once seemed divided by geography itself. It isn't just a bridge, it's a testament to what happens when courage, design, and engineering confront elements that refuse to cooperate. Stretching beyond the horizon like a ribbon laid across the sea, the Vasco da Gama Bridge doesn't just cross a river. It challenges the limits of scale itself. Spanning roughly 17 kilometers across the Tagus estuary, it ranks among the longest bridges in Europe. So long that much of the journey feels less like crossing a structure and more like driving over open water. Completed in 1998, after about 4 years of construction, this colossal megaproject was built to ease traffic congestion around Lisbon and coincide with the World Exposition of that year. But the real story lies beneath the asphalt. Engineers had to anchor massive foundation piles up to 95 meters into the ground to stabilize the bridge in soft estuary conditions, while also preparing it to withstand winds near 250 kilometers per hour and major earthquakes. At its core sits a cable-stayed section with pylons rising around 150 to 155 meters high and a main span of 420 meters, balancing enormous forces through tension rather than sheer mass. Even the deck itself isn't rigidly fixed. It can shift sideways and lengthwise, allowing the structure to absorb vibrations and seismic shocks instead of resisting them outright. And then there's the scale of logistics. 6 lanes of traffic, suspended over a protected natural reserve, requiring environmental safeguards, and even relocation of nearby residents during construction. This isn't just a bridge. It's a reminder that modern engineering sometimes doesn't fight nature. It adapts to it, bends with it, and survives because of it. In China's Sichuan province, there is a highway many drivers describe as something out of a dream or a nightmare. It's called the Yaxi Expressway, often nicknamed the road in the clouds, and once you see where it runs, you'll understand why. Stretching roughly 240 kilometers between Ya'an and Xichang, this route isn't carved through gentle countryside. It climbs through some of the most unforgiving mountain terrain engineers could face. A landscape so hostile it forced them to build not just a road, but an aerial maze of structures. Instead of hugging the ground, the highway leaps across valleys and burrows through rock. Along its path are about 270 viaducts and 25 tunnels, stitched together into a continuous transport corridor. The tunnels alone span roughly 41 kilometers, a reminder that much of the journey happens inside mountains rather than around them. Driving here isn't just travel, it's elevation. The route rises from about 1,970 feet to more than 10,500 feet above sea level, meaning vehicles can literally pass through cloud layers while crossing unstable terrain that includes multiple seismic fault zones. That combination of altitude, geology, and exposure is one reason it's been described as among the most difficult motorway projects ever attempted. And then there are the structures that carry the road itself. Take the Ganhaizi Bridge. Perched over 2,500 meters high, one of the first reinforced concrete truss bridges of its kind, stretching nearly 1.8 kilometers across open air. Or the towering piers along the route, some reaching heights above 180 meters, built simply to keep the roadway level enough for safe driving. Construction lasted from 2007 to 2012 and cost around 20.6 billion yuan, a price that reflects the brutal logistical reality of building infrastructure, where gravity, weather, and geology constantly fight back. Today, the Yaxi Expressway stands as proof that modern engineering doesn't just conquer distance. It negotiates with nature. Imagine building an entire neighborhood, not on land, but floating above one of the busiest rail yards in the United States. Hudson Yards isn't just another construction project. It's the largest private real estate development ever undertaken in U.S. history. A staggering $25 billion mega project spread across 28 acres on Manhattan's west side. Instead of clearing the site, engineers faced a harsher reality. Dozens of active train tracks carrying commuter and intercity rail traffic beneath them every day. Shutting them down wasn't an option, so they did something audacious. They built a massive steel platform over the rails and constructed the city on top of it. This artificial foundation now supports more than 11 million square feet of apartments, offices, and retail space, effectively suspending skyscrapers over moving trains and underground tunnels. Across roughly 18 million square feet of development, the complex includes residential towers, offices, cultural venues, retail centers, and public spaces designed to host tens of thousands of workers and residents. The tallest building, 30 Hudson Yards, rises about 1,296 feet, placing it among the highest office towers in New York. But the engineering challenge wasn't only structural. Constructing over live infrastructure demanded precise load distribution, vibration control, and ventilation solutions to dissipate heat and exhaust from trains below, a level of complexity that dramatically increased costs and technical risk. Love it or criticize it, and many urban planners do both. Hudson Yards represents a new urban experiment. A self-contained city within a city combining housing, workplaces, shopping, culture, and open space into a single engineered platform. It's proof that modern construction no longer just reshapes skylines. It creates entirely new ground where none existed before. Rising above Shanghai's skyline like something pulled from science fiction, the Oriental Pearl Tower isn't just a broadcast mast. It's a structural balancing act wrapped in steel and concrete. Completed in 1994 and standing about 468 meters tall, it was once the tallest structure in China and remains one of the city's most recognizable landmarks. Its design is unmistakable. 11 spherical structures connected by columns and beams, stacked along a slender vertical shaft. But behind the futuristic appearance lies a demanding engineering challenge. Supporting those massive spheres, including two primary observation decks suspended high above the ground, required a stable base formed by 3 enormous inclined columns anchored into deep foundations built to handle the soft river delta soils of Shanghai. The tower was designed to withstand extreme environmental forces as well. Engineers calculated resistance against powerful typhoon winds and seismic events common to the region, ensuring the structure could flex safely rather than rigidly oppose stress, a principle essential for very tall towers exposed to lateral loads. Inside, the tower functions as far more than infrastructure. It houses rotating restaurants, exhibition spaces, and viewing platforms that attract millions of visitors each year, blending telecommunications, tourism, and urban identity into a single vertical complex. What makes the Oriental Pearl remarkable isn't just its height or unusual geometry. It's the idea that architecture can become symbolism, turning a technical broadcast facility into a defining icon of a global megacity.
Out over the shimmering waters of the Yellow Sea lies a structure so immense it feels like humanity trying to stretch the horizon itself. This is the Jiaozhou Bay Bridge, a colossal roadway slicing straight across Jiaozhou Bay in eastern China, at roughly 26.7 kilometers long, with more than 25 kilometers of it spanning open water. This isn't just a bridge, it's one of the longest sea bridges ever built. A continuous corridor linking the urban heart of Qingdao with the industrial and airport districts across the bay. Construction took 4 years and tens of thousands of workers, using 450,000 tons of steel and over 2.3 million cubic meters of concrete, enough to rival the mass of dozens of Eiffel Towers. More than 5,000 concrete piles anchor the bridge to the bay floor, engineered to withstand earthquakes, typhoons, and even the impact of large vessels navigating the busy waters below. The road deck carries a 6-lane highway, cutting travel time across the bay by up to 30 minutes compared to the long coastal route. This two-shaped megastructure has multiple navigable sections, each spanning channels that are crucial for shipping traffic, and a design that blends pre-stressed concrete with cable and estate engineering on key spans. For engineers, Jiaozhou Bay Bridge wasn't just about being long. It was about mastering marine conditions, dynamic loads, and climatic extremes in one of the world's busiest coastal regions. When you drive across it, you're not just crossing water, you're traversing a continuous testament to scale, ambition, and precision, where human design meets the relentless expanse of the sea itself. Straddling the Colorado River between Nevada and Arizona, the Hoover Dam is more than concrete and steel. It's It's a testament to human daring and ingenuity. Completed in 1936 during the Great Depression, this colossal structure stands 221 meters tall, stretches 379 meters across, and was the tallest dam in the world at the time of its completion. Constructing it was an immense challenge. Workers carved through rugged canyons, diverted the mighty Colorado River, and poured over 4.4 million cubic meters of concrete, enough to pave a road from San Francisco to New York. To prevent the massive concrete from cracking, engineers embedded 582 miles of 1-inch steel pipes and circulated chilled water through them, cooling the structure block by block. Hoover Dam's reservoir, Lake Mead, stores up to 35 billion cubic meters of water, controlling floods, providing irrigation, and generating 2,080 megawatts of hydroelectric power for millions of people across Nevada, Arizona, and California. Its impact is both functional and symbolic, an emblem of progress, resilience, and human mastery over nature. The dam's arch-gravity design channels immense water pressure into the canyon walls, balancing colossal forces with precision. Even today, engineers marvel at the foresight and meticulous calculations that turned a rugged desert gorge into one of the most iconic engineering landmarks on Earth. Hoover Dam isn't just infrastructure, it's a monument to ambition, where human determination overcame geography, physics, and the hardships of its era to create something that continues to awe the world nearly a century later. Straddling the Colorado River between Nevada and Arizona, the Hoover Dam is more than concrete and steel. It's a testament to human daring and ingenuity. Completed in 1936 during the Great Depression, this colossal structure stands 221 meters tall, stretches 379 meters across, and was the tallest dam in the world at the time of its completion. Constructing it was an immense challenge. Workers carved through rugged canyons, diverted the mighty Colorado River, and poured over 4.4 million cubic meters of concrete, enough to pave a road from San Francisco to New York. To prevent the massive concrete from cracking, engineers embedded 582 miles of 1-inch steel pipes and circulated chilled water through them, cooling the structure block by block. Hoover Dam's reservoir, Lake Mead, stores up to 35 billion cubic meters of water, controlling floods, providing irrigation, and generating 2,080 megawatts of hydroelectric power for millions of people across Nevada, Arizona, and California. Its impact is both functional and symbolic, an emblem of progress, resilience, and human mastery over nature. The dam's arch-gravity design channels immense water pressure into the canyon walls, balancing colossal forces with precision. Even today, engineers marvel at the foresight and meticulous calculations that turned a rugged desert gorge into one of the most iconic engineering landmarks on Earth. Hoover Dam isn't just infrastructure, it's a monument to ambition, where human determination overcame geography, physics, and the hardships of its era to create something that continues to awe the world nearly a century later. rising like a twisting spiral into the clouds. The Shanghai Tower redefines what a skyscraper can be. At 632 meters tall with 128 floors, it is China's tallest building and the second tallest in the world. A shimmering beacon of ambition in the heart of Shanghai's financial district. What makes it extraordinary isn't just height, it's the twist. The tower rotates 120 degrees from base to top, reducing wind loads by 24%. And stabilizing the structure without massive additional materials. Engineers used a reinforced concrete core surrounded by a glass facade double-layered to improve insulation, ventilation, and energy efficiency. Inside, the Shanghai Tower is a vertical city. Office spaces, luxury hotels, observation decks, and retail zones are stacked with sky gardens every 14 floors, creating green oases that naturally circulate air and reduce energy use. High-speed elevators whisk passengers at up to 20.5 meters per second, making it one of the fastest in the world. Construction required cutting-edge techniques. Over 200,000 tons of steel, 79,000 cubic meters of concrete for the core, and precise engineering to handle Shanghai's typhoon winds and seismic activity. The twisting design isn't just aesthetic. It's a functional innovation that marries beauty with performance. From street level, it dominates the skyline. From above, it spirals gracefully, a symbol of China's technological prowess and unrelenting ambition. The Shanghai Tower isn't merely a building. It's a statement. Humanity can reach higher, twist bolder, and build smarter than ever before. Connecting the Atlantic and Pacific Oceans, the Panama Canal is more than a waterway. It is a colossal artery of global commerce, a monument to human determination carved across the Isthmus of Panama. Since its opening in 1914, it has transformed trade, enabling ships to save thousands of kilometers of travel around South America's Cape Horn. The canal is an engineering marvel. A system of locks, dams, and artificial lakes lifts ships over 26 meters above sea level, guiding them safely through narrow channels and dense rainforest. Each lock chamber is enormous, as tall as an 11-story building and capable of handling vessels weighing up to 4,000 tons. In the 2016 expansion, new locks were added to accommodate Neo-Panamax ships, some of the largest ever built. Each massive gate rolls on rails, requiring only a fraction of its weight and force to move, and water-saving basins recycle millions of liters with every transit. The project demonstrates not just scale, but precision, efficiency, and foresight. The Panama Canal is more than infrastructure. It's a bridge across continents, a bold manipulation of geography, and a reminder that with ingenuity, humans can reshape the flow of water and the flow of the world. Every ship that passes through is a testament to a century of vision, labor, and relentless engineering excellence.
Where most bridges simply cross water, this one disappears beneath it. Stretching between Denmark and Sweden, the Øresund connection isn't just a bridge. It's a hybrid engineering system that shifts form mid-journey, transforming from highway in the sky to tunnel under the sea. From the Swedish coast, drivers race across nearly 8 kilometers of elevated roadway suspended over open water, a structure carrying both cars and trains on the same span. But halfway across, something unexpected happened. The bridge touches down on an artificial island, and the route plunges into a roughly 4-kilometer underwater tunnel heading toward Denmark. Altogether, this coast-to-coast link stretches about 15.8 kilometers and combines multiple elements, bridge, island, and immersed tunnel, into a single continuous transport corridor. The central cable stayed section spans a busy shipping channel with about 57 meters of clearance, allowing major vessels to pass beneath without disruption. This unusual design wasn't just for spectacle. The tunnel portion prevents interference with aircraft operating near Copenhagen Airport, maintains shipping access, and protects the crossing from ice and harsh weather, constraints that shaped every engineering decision. Opened in 2000, the link physically connected the Scandinavian peninsula with mainland Europe's transport networks, reshaping regional travel and trade flows in ways ferries never could. Because sometimes mega projects aren't about building bigger. They're about solving problems so complex the solution has to exist above, on, and below the sea at the same time. In the heart of Singapore, where dense urban skyline meets the sea, an entirely different kind of landscape rises, not steel towers, but engineered nature shaped by technology. This is Gardens by the Bay, a futuristic park stretching across roughly 101 hectares along the Marina waterfront, designed to redefine how cities coexist with ecology. But the icons here aren't ordinary trees. They're the super trees, towering vertical gardens standing between about 25 and 50 meters tall, combining architecture, botany, and renewable systems into one structure. Look closer, and you'll realize these giants aren't decorative sculptures. They harvest solar energy through photovoltaic cells, channel rainwater for irrigation, provide ventilation for nearby conservatories, and support thousands of living plants, orchids, ferns, and tropical climbers growing directly on their steel frame. By day, they cast shade across the gardens. By night, they transform into glowing beacons during choreographed light and music shows, turning sustainability infrastructure into spectacle. Suspended between two of these structures is the elevated skyway, a narrow aerial walkway offering panoramic views across Marina Bay and the surrounding skyline, reinforcing the sense that this place sits halfway between science fiction and ecological engineering. And beyond the super trees lies an even broader vision: climate-controlled domes and artificial ecosystems built to simulate distant environments. Proof that modern urban design is increasingly about constructing nature as much as preserving it. Rising from the desert landscape of Dhahran, Saudi Arabia, stands a structure that looks less like a building and more like a cluster of giant polished stones frozen in motion. This is Ithra, officially the King Abdulaziz Center for World Culture, a place designed not just to be seen, but to reshape how culture and knowledge are experienced. Opened to the public in 2018 after more than a decade of development, the complex spans roughly 100,000 square meters and was built by Saudi Aramco, as a cultural initiative focused on education, creativity, and global exchange. Its architecture, designed by Norwegian firm Snøhetta, is wrapped in hundreds of kilometers of bent steel tubing, giving the exterior its shimmering, organic texture. Inside, it's not just galleries. It's an entire ecosystem: a library, museum spaces, cinemas, theaters, labs, and exhibition halls, all intended to connect heritage, science, and art in one environment. The centerpiece tower rises 18 stories above a cluster of sculptural volumes, symbolizing the project's goal of elevating ideas and creativity. Since opening, the center has drawn millions of visitors and hosted tens of thousands of programs and cultural activities, positioning itself as one of the region's most ambitious cultural hubs. In a nation globally associated with energy resources, Ithra represents something different: an investment in intellectual capital. Not a monument to extraction, but to imagination. Deep within Siberia's remote wilderness stands a wall of concrete, so immense it feels less like infrastructure and more like a barrier between worlds. The Sayano-Shushenskaya Dam rises over the Yenisei River, Russia's largest hydroelectric power station, a structure built to tame one of Asia's most powerful waterways. Towering more than 240 meters high, its curved concrete arch presses against the surrounding mountains with staggering force, holding back a reservoir that stretches hundreds of kilometers into the wilderness. But size alone doesn't define danger. This is engineering operating under relentless pressure, literally. Millions of tons of water push constantly against the structure, and inside the power station below, turbines convert that force into electricity for entire regions of Siberia. In 2009, the world saw just how unforgiving this environment could be. A turbine failure triggered a catastrophic accident inside the plant, unleashing a violent surge of water that tore through the turbine hull and killed 75 people. Investigations later pointed to mechanical fatigue and long-term vibration issues, a stark reminder that even the most massive infrastructure depends on microscopic tolerances holding together under extreme stress. Today, the facility has been rebuilt and modernized, yet the lesson remains carved into its legacy. When you harness nature at this scale, the margin between control and chaos becomes razor thin. Here, deep in Siberia, engineering doesn't just generate power, it negotiates daily with forces capable of overwhelming it. In the heart of Bangkok's jungle of skyscrapers stands a tower that looks like the city itself, glitching into 3 dimensions. This is MahaNakhon, a structure so striking that at first glance it feels less like a building and more like a digital fragment frozen in steel and glass. At approximately 314 meters tall with 77 floors, MahaNakhon was the tallest building in Thailand when it opened in 2016, piercing the skyline and redefining what a tower could look like in Southeast Asia. But its height isn't what makes it unforgettable. It's the facade. Instead of clean vertical planes, the tower side appears to have been carved with a swirling ribbon of staggered cubes that seem to peel away from the building's core. The effect is so unusual that from certain angles, it looks like a massive slice of the city was scooped out by some invisible force. That pixelated band isn't merely ornamental. It creates cantilevered terraces, skyboxes, and panoramic glass balconies, offering views both exhilarating and vertigo-inducing, while breaking wind loads and redistributing weight in ways no traditional tower ever attempted. Inside the structure, luxury meets engineering, upscale residences, high-end retail, and 2 premium hotels fill its floors, while a skywalk observation deck perched near the top give visitors a 360-degree panorama of Bangkok's sprawling metropolis below. At the heart of Rome, where history, faith, and sheer ambition collide, stands St. Peter's Basilica, a structure so monumental it seems to defy both time and gravity. Completed in 1626, after more than a century of design and construction, it covers roughly 23,000 square meters and is one of the largest churches in the world. Its central dome, designed by Michelangelo, soars over 136 meters above the floor, dominating the skyline and inspiring awe from miles away. Building it wasn't just architecture. It was a feat of engineering. Engineers and artists had to solve unprecedented challenges, supporting a massive dome on a square base, constructing enormous columns and arches that could carry tens of thousands of tons of stone, and designing the interior so that every line, sculpture, and fresco created both spiritual and visual harmony. The basilica incorporates millions of bricks, travertine stone, and marble, all arranged with precision that modern engineers still study today. Even the famed baldachin of Bernini, the towering bronze canopy over the main altar, required clever structural solutions to stand atop the columns without compromising stability. And yet, what makes St. Peter's Basilica truly extraordinary isn't just its size or materials. It's the vision of generations of artists and engineers collaborating to create something that has lasted over 400 years, surviving earthquakes, wars, and centuries of human activity. A structure where ambition, faith, and ingenuity converge in physical form. Every step inside the basilica reminds visitors, this isn't just a building. It's a declaration of human creativity, an icon that shows what's possible when bold vision meets extraordinary skill. In the megacity of Wuhan, engineers didn't just build another rail line, they flipped the idea of a train on its head. Instead of running on tracks like every subway or elevated railway you know, the Optics Valley suspended monorail hangs from them. Passengers glide through the air with nothing beneath their wheels but open space and skyline. A rail car suspended from an overhead beam, giving a surreal perspective of the city below. This system, nicknamed the Optics Valley Photon, isn't a prototype. It's China's first commercial suspended monorail line, officially opened in late September 2023. Phase 1 stretches about 10.5 kilometers and serves 6 stations, weaving through the high-tech Optics Valley corridor between Jufengshan and Longquansha. What sets this apart isn't just its aerial nature, it's the experience. The trains run at up to 60 kilometers per hour, fully driverless and automated, departing at regular intervals throughout the day. Beneath your feet, transparent floor panels that turn every commute into a 270-degree aerial tour of urban forests, parks, and cityscapes. Beyond the futuristic thrill, the suspended monorail represents a leap in urban transit thinking, integrating sightseeing, technology, and everyday movement into one system. It demonstrates how cities are reimagining public transport, not just for efficiency, but for spectacle. Here in Wuhan, transit isn't just about getting from A to B, it's about redefining what rail travel feels like above the ground. Long before modern skyscrapers and meta projects, one city built defenses so formidable they held for over 1,000 years. The walls of Constantinople weren't just stone barriers, they were the embodiment of strategy, ingenuity, and sheer human determination. Constructed under Emperor Theodosius II in the 5th century, these walls stretched roughly 6.5 kilometers, consisting of a triple-layered system, a moat, an outer wall, and a massive inner wall that reached up to 12 meters thick and 12 to 20 meters high. Engineers faced a unique challenge. The city sat on a peninsula, surrounded by the sea on three sides, but vulnerable to sieges from the land. Their solution was a layered fortification with over 90 towers spaced at intervals, allowing defenders to rain arrows and pour boiling oil on attackers, creating a barrier that seemed insurmountable. Over centuries, the walls survived countless sieges, including attempts by the Arabs, Bulgars, and Rus. Even in 1453, when the Ottoman forces finally breached the city, it wasn't because of weak walls. It was the result of artillery, strategy, and relentless determination, not poor engineering. The construction combined local limestone, bricks, and massive mortar layers, forming a structure that modern engineers still admire for its durability. Portions of the walls remain standing today, a testament to the ingenuity and foresight of the Byzantine architects who envisioned a defense capable of lasting centuries. Imagine a road carved out of the most hostile terrain on Earth, a ribbon of asphalt gripping sheer mountain walls, clinging to cliff edges, and vanishing into the clouds above 4,700 meters. This is the Karakoram Highway, a lifeline between Pakistan and China and one of the most astonishing feats of civil engineering ever attempted. Stretching nearly 1,300 kilometers from Hassan Abdul in Pakistan's Punjab province all the way to Kashgar in China's Xinjiang, this highway doesn't just link two countries. It stitches together ancient Silk Road culture with modern global trade. Along the way, it threads through some of the planet's most rugged landscapes, gigantic glaciers, plunging valleys, roaring rivers, and peaks that tower above 8,000 meters, mountains that dwarf most skyscrapers. At its highest point near Kanjarat Pass, the road climbs to approximately 4,700 meters above sea level, making it one of the highest paved international border crossings in the world. Building it was anything but simple. The Karakoram Range is notorious for avalanches, rockfalls, and landslides, natural hazards that forced crews to work in extreme cold, oxygen-thin air, and unstable geology. Despite this, Pakistani and Chinese engineers completed the colossal route in the late 1970s, opening a passage where none had existed. This is more than a road. It's a strategic artery for trade, a gateway for tourism, and a testament to human tenacity against nature's most unforgiving theaters. But that tenacity came at a cost. Harsh conditions and unpredictable terrain make travel here both breathtaking and perilous. Driving the Karakoram Highway isn't just sport. It's a journey across history, culture, and geography, where every hairpin turn reveals landscapes that seem almost too dramatic to be real. Rising from the banks of the mighty Yangtze River, the Three Gorges Dam isn't just a hydroelectric project. It's a leviathan of engineering, a structure so massive it reshaped both the landscape and the flow of history itself. Stretching 2.3 kilometers across and standing 185 meters tall, this dam holds back a reservoir containing approximately 39.3 billion cubic meters of water, enough to fill 11,000 Olympic swimming pools. Its hydroelectric plant generates around 22,500 megawatts of power, supplying roughly 10% of China's electricity demand. The turbines themselves are colossal, each the size of a small building, capable of producing more energy than most entire power stations worldwide. But the Three Gorges Dam is more than electricity. It tames floods that historically devastated millions, manages water transport, and even reshaped shipping routes. Ships now pass through the world's largest ship lifts, rising 113 meters in under 40 minutes. The scale of the project is staggering. Construction required 27 million cubic meters of concrete, enough to cover the island of Manhattan, and involved relocating over 1.3 million people from the flooded reservoir area. Engineers had to balance immense water pressure, seismic risks, and environmental impacts, making this one of the most complex infrastructure projects in human history. The dam's effects are global. Scientists calculated that the mass of water has slightly altered the Earth's rotation and shifted its poles by centimeters. In other words, humanity's reach extended literally to the movement of the planet. Here, engineering doesn't just bend nature. It negotiates with it, shaping rivers, mountains, and lives on a scale almost impossible to fathom. On the glittering waterfront of Baku, where the Caspian Sea meets the skyline of a rising metropolis, a building is taking shape that feels like architecture rewriting geometry itself. This is the Crescent Development, a collection of towers and an iconic crescent-shaped structure designed not just to be tall, but unmistakable. Part of a visionary mixed-use complex along the Caspian coast, the project includes a curved crescent-shaped hotel built on an artificial island, an office skyscraper known as Crescent City rising roughly 210 meters high, and a residential tower with retail space, all arranged to form a silhouette that echoes the crescent moon on Azerbaijan's flag. This isn't simple vertical construction. To create the crescent form of the main hotel, engineers had to first reclaim land from the sea, driving hundreds of reinforced concrete piles up to 76 meters deep into the seabed to anchor the foundations where none existed before. Then came another technical marvel: the dramatic curved span that arches between the offshore hotel's twin supporting towers was pre-assembled on the ground and lifted into place with precision cable systems, a feat rarely attempted on such a scale. The effect is unmistakable at sunset. Glass and steel reflect the shifting light over Baku Bay, turning the complex into a luminous crescent floating above the water. For engineers and architects, this project wasn't just about height. It was a test of structural ingenuity, material performance against strong seaside winds, and coordination across land and water.
In the heart of London's Paddington Basin, there's a bridge that doesn't behave like any bridge you've ever seen. This is the Rolling Bridge, an engineering marvel that curls into itself like a living organism, challenging every notion of what a bridge can do. Instead of spanning the water in a conventional way, the bridge folds up into an octagon to allow boats to pass beneath. At first glance, it looks like a static piece of art, but at the push of a single button, hydraulic mechanisms fold the 8 triangular sections, lifting the bridge off the canal and creating a dramatic, spiraling motion that feels almost magical. Designed by Thomas Heatherwick, the Rolling Bridge wasn't just about function. It's a fusion of art, architecture, and engineering. Its structure uses precision steel links, carefully balanced hydraulics and tension cables so every movement is smooth, reliable, and visually hypnotic. At just 12 meters long, it's compact, but its mechanism is intricate. Each fold redistributes weight, each hinge bears enormous tension, and the bridge transforms from a walkway to a sculpture in seconds. A kinetic masterpiece that proves even small-scale structures can defy expectation. For pedestrians, it's a simple crossing. For engineers, it's a marvel of creativity and precision. The Rolling Bridge isn't just infrastructure. It's a reminder that engineering can surprise, delight, and challenge the very idea of possibility. Rising from the heart of the desert like a spear piercing the sky, the Burj Khalifa is more than a skyscraper. It is the ultimate statement of human ambition. At a staggering 828 meters tall with 163 floors, it has held the title of the world's tallest building since 2010, dominating the Dubai skyline and redefining what's possible in vertical construction. But height alone doesn't tell the story. Burj Khalifa's Y-shaped floor plan isn't just aesthetic. It enhances stability, reducing wind sway at extreme altitudes. Its hexagonal central core combined with 3 radiating wings allows engineers to resist torsion and lateral bending, ensuring the tower remains steadfast even under desert storms. Construction required ingenuity on a scale never seen before. 330,000 cubic meters of concrete, 103,000 square meters of glass, and over 39,000 tons of steel rebar, all fused to create a vertical monument to engineering. Tower cranes climbed higher than any before, and the elevator system, the fastest in the world, propels occupants at 10 meters per second. Burj Khalifa isn't just a building, It's a vertical city. Luxury residences, offices, hotels, and observation decks all exist within a structure that pushes the limits of materials, design, and human ambition. Even the cladding had to withstand extreme desert temperatures while reflecting sunlight to reduce energy demands. It stands as a symbol of boldness and precision, proving that with the right vision, humans can reach heights once thought impossible. In Dubai, the Burj Khalifa doesn't just touch the clouds, it challenges them. At the heart of Singapore's Jewel Changi Airport, water doesn't just flow. It falls in a spectacle that seems almost otherworldly. This is the Rain Vortex, the world's tallest indoor waterfall, plunging 40 meters from a glass-domed ceiling into the lush indoor forest below. But this isn't just a waterfall, it's a marvel of engineering and environmental design. The water circulates through a recycled rainwater system, flowing through precision-engineered channels and misting systems to create a constantly moving cascade, while conserving every drop. At night, a choreographed light and mist show transforms the vortex into a living sculpture of water, glass, and illumination. Surrounding the waterfall is a multi-level forest of over 2,000 trees and thousands of shrubs, connected by suspended bridges and spiraling walkways, creating the sensation of walking through a vertical rainforest. Engineers had to calculate air circulation, humidity, and acoustics to maintain comfort, while supporting the immense weight of both water and vegetation. The Rain Vortex isn't just architecture, it's an immersive experience, blending nature, technology, and human creativity. Here, every droplet tells a story of precision, imagination, and the ability to turn a functional space into a world-class spectacle. In Singapore, water doesn't just fall. It performs, mesmerizes, and defines the skyline from the inside out. Deep in the hills outside Nanjing lies one of the most extraordinary abandoned projects in world history. Not a bridge or a tower, but a stone monument so colossal it was impossible to move. This is the Yangshan Stele, a monumental slab of rock carved from the mountainside during China's Ming Dynasty, and then abandoned forever. In the early 1400s, the Yongle Emperor, the same ruler who built the Forbidden City in Beijing and sponsored Admiral Zhang Yi's treasure fleets, ordered a stele of unprecedented size to commemorate his father's mausoleum. Engineers and craftsmen chiseled 3 separate sections out of Yangshan Mountain: the base, the body, and the crown, each so massive it dwarfs most ancient monuments. Had the pieces been assembled as intended, the stele would have soared over 70 meters tall, weighing tens of thousands of tons, a stone monolith of imperial power and monumental scale. But then reality struck. The stones were simply too big to transport or erect. The terrain was brutal, and no practical method existed to haul these megaton slabs through the mountains down to the mausoleum site. Rather than completely impossible, the project was abandoned in place, leaving the colossal remnants frozen in time. Across the frozen wilderness of Alaska, a river of steel snakes through mountains, tundra, and permafrost. This is the Trans-Alaska Pipeline System, one of the most audacious feats of industrial engineering on Earth, stretching 287 kilometers, 800 miles, from Prudhoe Bay in the Arctic north to Valdez on the southern coast. It carries crude oil from the oil fields to the shipping ports, defying extremes that would stop almost any other infrastructure project. The pipeline isn't just long, it's a masterclass in engineering adaptation. Much of it is elevated above the ground to preserve permafrost and prevent melting from the heat of the oil, while certain sections dive beneath rivers, roads, and earthquake-prone terrain. Its 800-plus pumping stations support structures, and over 1 million valves work in unison to maintain a flow of nearly 2 million barrels of oil per day at peak operation. Engineers faced extremes, temperatures dropping below 50 degrees Celsius, 58 degrees Fahrenheit, violent winds, rugged mountains, and seismic zones. To combat earthquakes, special sliding supports allow the pipeline to move safely without breaking, while insulated sections prevent permafrost thaw that could destabilize the entire route. TAPS was completed in 1977. taking just 4 years despite the harshest environmental conditions imaginable. Its construction required over 70,000 workers, nearly 1.2 million tons of steel, and innovative techniques to overcome a landscape that seemed almost designed to defeat human ambition. Imagine stepping into a world where the sky meets the ocean, where palm trees sway above crystalline waters, and every building seems to float between heaven and sea. This is the Tropical Island Resort, a marvel of human design and harmony with nature, where luxury meets imagination. From aerial view, the resort stretches across artificial lagoons, coral-shaped islands, and interconnected waterways, each villa designed for privacy, comfort, and breathtaking views. Architects and engineers have carefully sculpted the land to withstand tides, storms, and erosion, blending structural resilience with visual perfection. Many of these resorts are built on reclaimed land or tiny islands, which means every foundation is a feat of engineering. Piles driven deep into the seabed stabilize bungalows and bridges, while sophisticated drainage and water circulation systems maintain the delicate ecosystem that surrounds them. Archdaily.com. But it's not just about engineering, it's about experience. Infinity pools seem to spill into the ocean. Glass floors reveal coral reefs below, and walkways curve like natural rivers, guiding guests on a journey of awe and serenity. Designers leverage natural airflow, solar orientation, and shade structures to create comfort without harming the environment. The result is a place that feels almost surreal, floating paradise where human ingenuity meets tropical splendor, and every corner invites visitors to lose themselves in beauty, adventure, and tranquility.